Alright, let's do some equations here. We've been talking about polar and rectangular, and we know there's a relationship between polar and rectangular. So now we are going to take equations and convert them. If they're in rectangular form, we're going to put them in polar form and vice versa. So what this means is that if I'm given an equation in rectangular form, notice that you recognize it's in rectangular form because it's got an x and a y. If you're going to polar form, you want everything with r and theta, either both r and theta or just r or just theta, but you can't have any x's or y's in it. Alright, so let's go back to what we know, and I'm just going to briefly show this because when I'm talking about them, we've already come up with all this. We've already used these several times, so this is what we're going back to here. And we know that x squared plus y squared equals r squared. So if I substitute that in, then I know r squared equals 9, which means r is 3. And you're pretty much done. Once you've got everything in terms of r theta, you're good to go. And you should really recognize this anyway. This is standard form of an equation of a circle. We know that this is a circle at center 0, 0, and with a radius of 3. So this circle is going all around with a radius of 3. Alright, and when I write this in rectangular, when I take it from rectangular form to polar form, I've got r equals 3. Well, that's my distance, and it really doesn't matter what my theta is. My theta, regardless of what it is, my r is always 3. So that gives me the same graph. So I've got a circle with radius of 3 there. Alright, I don't want to get bogged down in all that, so let's just keep going. Alright, so now we've got this equation that says y equals 5. Alright, by definition and by what we've already know, when we're converting from rectangular to polar, polar to rectangular, we know that y equals r times the sine of theta. So if r times the sine of theta, that's y. And I set that equal to 5. Now I'm just going to solve that for r, which means I'm going to divide both sides by sine of theta. And so r is going to equal 5 over sine of theta. And if I really wanted to clean that up, you could be good to go here, but if I really wanted to just get this simplified, then I know that 1 over sine of theta is cosecant of theta, and that would be times 5. Alright? Alright, let's go the other way with it. So now we're going to go from rectangular, from polar to rectangular. So now I've got r and theta in my equation, and I only want x and y in my equation. Alright, and we did this one similar. We ended up with r equals 3 when we converted that first equation, so you might already have an idea of what's going to happen here. But if I were converting that, remember that x squared plus y squared equals r squared. So I need this to be an r squared. Well, that's real easy to do if I square both sides. Right? If I square both sides, I got an equation. As long as I do whatever I do to one side, I can do to the other. So this is going to be r squared equals 9, which means x squared plus y squared equals 9, and I'm done. Alright, I've got everything in terms of x and y, and you can guess this is a circle with a radius 3. And notice that r was negative 3 here, but that's not going to change anything. Just remember, when you graph and your r is negative, you just go the opposite direction. Alright, but it's still going to give you the same circle. Alright, so 58 is r equals the cosine of theta. So this is in polar form, and we want it in rectangular form. So I don't want any r, any theta left in my equation. I just want it in terms of x and y. Now I know that r times the cosine of theta equals x. I know that r squared plus equals x squared plus y squared. So what do I need to do there? Well, the first thing I need to think about is the previous equation. I squared both sides to get r squared. If I square both sides, this is just going to complicate things and give me a cosine squared, so that's not really what I want to do. But what's going to happen if I multiply by r? Well, if I multiply r by r, I still get r squared. And if I multiply this side by r, so I get r squared equals, and remember the order in multiplication doesn't matter, so I could write this as 6 times r times the cosine of theta. Well, we know that this is x, and we know that this is x squared plus y squared. So now I've got x squared plus y squared equals 6 times x. Okay? Now, at this point, if I were looking for rectangular form, I would be done. I've got everything in terms of x and y. I don't have any r's. I don't have any thetas. If I want to take it to the next step would be writing it in standard form. So if I were writing this in standard form, I would put my x's together. So I would subtract 6x. I would put my y's together. I only have one term with y in it. And that equals 0. And then I would get my perfect squares here. So I need to complete the square here, and -6. Half of -6 is -3 squared is 9. So that's the value I would add to make this a perfect square trinomial. Whatever I do to one side, I have to do to the other side. So when I write this, and my y squared is already a perfect square, so I don't have to complete the square there. So if I write this as a perfect square, I get x minus 3 squared plus y squared equals 9. And this is still an equation of a circle with radius at 3, 0. I mean with center at 3, 0 and with radius at 3. And like I said, once you've got it in terms of x and y, you're good to go. But this is just taking another step. Alright, 62 is r equals 2 minus the cosine of theta. And once again, I don't want to square both sides because that's going to make that all a mess. But if I multiply everything by r again, like I did in that equation above, if I multiply that by r, I get r squared, which is a good thing because I know how to write that in terms of x and y. When I distribute that r, I get 2r minus r times the cosine of theta. Alright, now we've gone a little bit, but we still have some things to take care of. So I know how to write this in terms of x and y. I know how to write this in terms of x and y. So let's put that together. So we've got r squared. I'm going to take that over. So that's going to be plus r cosine theta equals 2r. Alright, and I could go ahead and write this in x and y. So this is x squared plus y squared. This is x equals 2r. Alright, so now I'm pretty much starting over. I've got my x's and my y's over here. I need this to be an r squared. Well, let's just square both sides. We don't want to multiply by r because then I'm going to have an r over here. But if I square both sides, this is giving me an r squared over on this right side, and that's what I want. I'm just going to leave that like it is. I'm not going to do anything with that. And I know that 2r squared is 2 times 2, which is 4r squared. Alright, and now I know that r squared is x squared plus y squared, so this thing is just going to be x squared plus y squared plus x. That whole thing is squared equals 4 times x squared plus y squared. Everything's in terms of x and y, and I am good to go.